Welcome to the video homework for density. There are two things that you need to be able to do with density. First of all, you need to qualitatively evaluate density. Is this material dense? Is this material not dense? Is it more dense? Is it less dense? That sort of thing. Secondly, you need to be able to quantitatively evaluate density, meaning do calculations. So first, let's define density. The definition of density is how closely the molecules are packed. So all substances are made of molecules. All those molecules have some amount of space in between. A molecule that is solid will be very closely packed. Solids are very dense. Liquids have a little bit of space in between them. And then gases are spread way far apart. Solid, liquid, gas. So solids are much more dense. Liquids are in the middle, and the gases are the least dense because their molecules are farther apart from each other. What's in between these molecules in the gas? Nothing. Empty space. That's how it can be less dense. Any two objects made of some same substance have the same density. So if you have two pieces of oak wood that are different sizes, they'll still have the same density. And that's why all pieces of oak will float in water, because the density is less than water. Every substance has a unique density, so you can identify substances based on their density. If you have a list of possible densities of different substances and you have an unknown, you can compare its density to that list and figure out what it is. Because density is how closely the molecules are packed, it is affected by two things, mass and volume. If you're comparing two objects and one of the objects has more mass but the same amount of volume, then its density will be greater. So if they have the same volume but more mass, higher density. If they have the same mass but one of them has more volume, then it will have the lower density. This is because the molecules are less tightly packed. They're more spread out because it has more volume. It's the same number of molecules because they have the same mass. In this case, you have more molecules in the same space, and so it's more dense. That is how you qualitatively evaluate density. Let's talk about quantitatively. Quantitatively, density is the mass divided by the volume. Hopefully you've seen this formula before. In order to use this formula to calculate density, you're going to follow these three steps. First step, rearrange the formula, if necessary, to solve for your desired variable. So if you need to solve for m or you need to solve for v, you need to rearrange the formula. If you're solving for d, you don't have to. Secondly, once you've got the formula the way you want it, plug the numbers in. Then, after you get an answer, you have to round your answer to sig figs, because we always round our answers to sig figs, except when you're doing the online homework. And then make sure you include a unit, because we don't have naked numbers just lying around. We have to have a unit after the number. So let's try this practice problem. What is the volume of 13.1 grams of chlorine if its density is 0.0032 grams per centimeter cubed? All right, so let's start off with our formula. Density equals mass divided by volume. I don't want to solve for density. I already have density. I want to solve for volume. So I need to rearrange this formula to solve for volume. So in order to do that, I have to get the volume out of the denominator. Can't do anything with something in the denominator. So we're going to multiply both sides by v. So now I have v times d equals m. In order to solve for v, I now have to divide both sides by d. And v equals m over d. All right, now that I have the formula solved for the variable I want, I can start to plug in numbers. My mass is 13.1 grams. My density is 0.0032 grams per centimeter cubed. I put these numbers into my calculator, divide 13.1 by 0.0032, and I get 4,093.75. The grams up here cancel out with the grams down there, and that leaves us with centimeters cubed. However, this has 6 sig figs in it. How many sig figs should we want? Let's go back to the question. We are not going to take our sig figs from the density because that is not a measured value. That is a standard value. The only thing that's been measured in this question is our volume. How many sig figs does the volume have? Hopefully you know it's 3. So if our volume has 3 sig figs, then our answer should have 3 sig figs, not 6. So again, as you learned when we did sig figs, in order to round to the right number of sig figs, we're going to draw a box. starting on our left, including 3 sig figs. This 3 is not big enough to round that up, so we stick with 409, but we have to change the 3 to a 0 because we want to hold the place. We don't want to change our answer from the thousands down to the hundreds. However, these numbers we do not include because they are to the right of the decimal. If we put a decimal in there, we would start to have more significant figures. So the answer is 4,090 centimeters cubed. Thank you.